Hi, so we are going to work on 5.2. This is bisectors in triangles. So as far as this vocab is concerned, we're going to go through the vocab as we do the examples. And so you will be able to learn what the words are as we're working through it. I want to point out that right here, I have a triangle. And in this triangle, I have each side is bisected. So the line is cut in half. And this here has a line that makes a 90-degree angle. And I want to point out to you that the line is not a perfect straight line. The line actually has a little bend in it because once it hits the center point, the point of concurrency right here, point P, once it hits point P, then it might have to do a little bend to get to the other vertex, vertices we call these. So right now I've got three lines, and the lines are formed by perpendicular bisectors on one side. So I want to point out that PA is the same as PB is congruent to PC. Okay? So the sides are bisected. And the interior lines from the vertex vertices are congruent. Okay, so those are the two things to remember when doing this. Then, you know, like if you were to draw a circle around this triangle, wherever the three lines hit is located in different spots. In an acute triangle, it's here in the middle of the triangle. If I have a right triangle, my point of concurrency is on the hypotenuse. And if I have an obtuse triangle, it's on the outside of the triangle itself. So this right here has sides that are bisected, equal congruent sides, cut in half, and then these middle lines are congruent, and those lines come from the corners, the angles. So the next thing I'm going to talk to you about is an incenter and inscribed. Incenter is where if I'm going to have angle bisectors, so that's important, angle bisectors, so the angles are cut in half. And those are equal from all three sides, which means, I'll show you. Let me explain this one first. An inscribed means that I'm going to have a triangle, and then there would be like a circle inside of it. Ah, how bad is that? I'm sorry. Oh, you can't see. So there's a circle inside the triangle. Okay? That's what inscribed means. Inside. Okay, I'm going on to the next page. So here I've got an incenter a point in the middle, and the angles are bisected. And the interior lines from the sides are congruent. Okay? The point of concurrency where the three lines hit is called the incenter. All right, so I know it's hard to see, but you have it on your worksheet. These two lines are congruent, guys. This is from the perpendicular bisector. That's from the front page, remember? And it is that the interior lines from the vertices, from the angles, are congruent. So I'm going to set, is it 3x plus 7, you guys?
Yeah, it's plus 7.
5x minus 3. Wow, this is a horrible photocopy. I'm sorry. So I'm going to go ahead and solve. Okay, then you add 3 to both sides. Right? And x equals 10. I'm sorry, 5. But Fy is 3 times x plus 7. So it's 15 plus 7. So Fy is 22. Because it's asking us specifically to find Fy. Good. Now let's do example 2. Same thing, guys. The congruent sections are right here. So BO is congruent to AO. So set them equal to each other. Two x minus 3 equals 6. And 2x equals 9. 9 halves is the same as 4 1/2. But it's asking us to find the radius. You guys, the radius is AO or BO. So I could plug it in for either. 6 plus 2 times 4 1/2. 6 plus 9. The radius is 15. Okay. All right. Now I'm switching gears and I'm going to have you look at this is like the incenter. And these are congruent. They might not look it, but they are. Okay? And the angles are bisected. So that means that this is 31. And this is 28. And this is, I don't know, we'll have to figure it out. Okay, now, the question says, find ST. Well, isn't it true that ST is the same as SU is the same as SR? Because check it out. I know this 8 and 10, but I have to find SU. So step 1. Find SU using Pythagorean Theorem. A squared plus B squared equals C squared. And here's the triangle. I'm flipping it and I'm turning it, but it's still SUP. 10 and 8. So I need to find SU. Do you remember Pythagorean Theorem? You guys? Yep. A squared plus 8 squared equals 10 squared. A squared plus 64 equals 100. minus 64. A squared equals 36. So, A equals 6. That means that the SU equals 6. And that means that ST equals 6. Therefore, 3 dots, ST equals 6. Okay, then it says, find the measure of SPU. Well, here's the triangle that I know so far. M, N, P. This 31 plus 31 is 62, correct? (28 plus 28 is 40 plus 16, 56. There's 56 degrees. Well, what's missing? So we work on we work on a calculator, let's say, and I'm like, okay, 56 plus 62 is 118. And then I do 180 minus 118, 62 degrees. So this is 62. But angle is half of 62. So the measure of angle SPU is 31 degrees. Lastly, for example 4, okay, what's happening here? Oh, the angle is being bisected. This is so it's an incenter, which means, oh wait, yeah, it is an incenter. Oh my gosh. Which also means that this is congruent to this. So QP is congruent to RP. So do the math. 3x plus 3 equals 5x minus 3. You just set the two equal to each other. And then I'm going to do (6 equals 2x, x equals 3). It says the radius of the inscribed circle. You guys, the inscribed circle would look like that. So the radius of the inscribed circle is RP and QP, which is 5 times 3 minus 3, 15 minus 3. The radius is 12. Very good.